All right, geometry, we are in lesson 7 of our unit 4, where we are going to talk about equations for lines using normal segments. Okay, this is a new vocabulary word that we will get to as we go through the lesson. Cool? All right, first of all, we're going to do a little bit of review. All right, the equations given are in standard form. Put each equation in slope-intercept form. State the slope and the y-intercept. So standard form, we haven't done standard form. You may have learned it in Algebra 1. Little reminder. AX plus BY equals C, where A, B, and C are all integers. Standard form to me is not very useful. Slope-intercept form is where we need to go with each of these. So slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept, where x equals 0. All right, so let's do that. Subtract 6x from both sides. 3y equals negative 6x plus 12. Divide everything by 3, everything. Y equals negative 2x plus 4. My slope is negative 2. My y-intercept is 4. Subtract 5x from both sides. I have 7y equals negative 5x plus 14. Divide each piece and part by 7. Y equals negative 5/7 x plus 2. My slope is negative 5/7. Y-intercept is 2. Cool? Last one. Get that y by itself. Negative 5y equals negative 2x minus 7. This one's sort of messy, but it's no big deal. Divide everything by negative 5. I have y equals 2/5 x minus 7/5. My slope, see I have two negatives here. Two negatives equal positive. Slope is 2/5 and y-intercept is negative 7/5. Cool. That's it. Moving on. All right. So what we're working through today, this isn't in your classwork, but it's sort of setting the stage for what we're doing. Okay, we're continuing to use that perpendicular criterion for perpendicularity equation that we learned. Yeah, we're going to continue to use that. So let's go ahead and work through this. So we have this drawing here. I have A, which is ordered pair AB, which lies on line L. So I have line L right here. Point A lies on line L. Point B does not lie on line L. And AB is perpendicular to line L. At any point P on line L will satisfy the relationship that AP is perpendicular to AB. AP is perpendicular to AB. Because P is on line L, and line L is perpendicular to line AB, so this is on this line. We've already said that this line and this segment are perpendicular. Therefore, this segment will be perpendicular to that segment because this point lies on this line, or it lies on that segment. Okay, so draw the picture described. Check. All right. The next thing we're going to do is prove that these are perpendicular by translating your right angle to the origin. Your right angle has to be the one at the origin, so let's go ahead and translate it. I'm going to do minus A and minus B to get there. So we're going to have A prime is A minus A, which is 0, B minus B, which is 0. Point B prime, which will be C minus A, and D minus B. And then P prime, X minus A, y minus b. Okay, those would be the translated points. Let's look at them. Translate the points. Check which points should be on the origin. Well, the right angle should be on the origin. On the origin. What is the translation used? We did minus a and minus b. A is the common point, so that should be translated to the origin. The translation is minus a minus b to get point A at the origin. The translated points are given, which we did on the previous slide. This should not be new to you. Cool? Let's see what we're going to do with it. All right, if the segments are perpendicular, what equation should hold true? Okay, this is the thing we've done a few times. We're going to multiply the x values and add them to the y values. So c minus a times x minus a plus d minus b times y minus b will have to be equal to 0. That equation has to hold true for those segments to be perpendicular, right? All right, so if A, we're just saying c minus a, and b equals d minus b, write this equation substituting a and b. So write this equation substituting a and b. So we're going to have a times x minus a plus b, d minus b equals 0. Which line have we written the equation of? Okay, which line have we written the equation of? We end up with the equation of the line that passes through point A that is perpendicular to AB. So this right here is the equation of the line through A perpendicular to segment AB. That's what this line is. So go ahead and jot that down. Okay, we'll do something with it. All right, we just finished up to this point. So what do A and B represent graphically? A is called the abscissa. It's a new word, isn't it? And B is the ordinate of the image of point B. Very high level. Okay? Here's where we get into a new vocabulary word, though. We call segment AB a normal segment to line L because it has one endpoint on the line and is perpendicular to the line. This is something we're going to have to remember. Normal. And obviously we aren't going to do this. So we have a definition here. A line segment with one endpoint on a line and perpendicular to the line is called a normal segment to the line. All right, the rest of the lesson's pretty simple. That was sort of the hardest thing, right? All right, let's try a practice problem. I'm going to tie what we just did in the past few slides into what we're doing now. Given A and B, find an equation for the line through A and perpendicular to AB. So we're finding the normal line. So graphically what I'm trying to do, I've got A and B. I want an equation for a line through A and perpendicular to AB. So I'm trying to find the equation for this line. So I'm going to add a point P to it. Okay, we know that AB, so I'm trying to find this normal line, that right there. Line AP, oh goodness. AP, this is what I'm trying to find. Cool. All right, so let's get our point A to the origin. So I'm going to subtract 5 and add 7. A prime is now 0, 0. B prime is subtract 5, add 7. And P prime, x minus 5, y plus 7. Cool. All right, let's do our math. I'm going to have 3 times x minus 5 plus 9 times y plus 7. Okay, pause for a second. If I look at this equation right here, I just did the whole big A times the parentheses and big B times the parentheses. Okay, this right here is an equation for a line. Right there. I've got an x and a y, a multiplier, some constants. I now can rearrange this into standard form or the slope-intercept form. Now, I'm a big proponent of the slope-intercept form. You write it in a slope-intercept form and all the numbers make sense. We know their purpose. So that's what we're always going to do. But I just wanted to say this is what we just did in the past few slides. I have big A times parentheses, big B times parentheses equals 0. Cool? All right, let's simplify this guy. Okay, distribute. 3x minus 15 plus 9y plus 63 equals 0. Collect your constants. 3x plus 9y. My constants are negative 15 and positive 63. That gives me 48. Okay, 3x. I'm going to subtract 48 from both sides. And then I'm going to subtract 3x from both sides. I'm going to divide everything by 9. Negative 3 over 9x plus 48 doesn't go into 9, so we're going to leave that. 48 over 9. I can simplify it though. Y equals negative 1/3 x plus, let's see, I can divide both the top and the bottom by 3. There's my equation for the line that's through point A and perpendicular to AB. Cool? Okay, let's do it again, except I'm going through point B and perpendicular to AB. That means I want B to be at my origin. So let's write in blue. Now I'm going to subtract 8 and subtract 2. A prime is minus 8 and minus 2. B prime minus 8 minus 2, and P prime x minus 8, x minus 2. Awesome. Okay, there's my origin. So let's multiply with A and P. Negative 3 times x minus 8 plus negative 9 times x minus 2 should equal 0 for them to be perpendicular. Distribute. Oops, I forgot my x. So distribute. Negative 3x plus 24 minus 9x plus 18 is 0. Collect like terms. Negative 3x plus, minus 9. Where'd my y go? I messed up. I bet you guys already caught it, didn't you? Sorry about that. I hope that didn't confuse you too much. 24 plus 18. 8. That gives me 12. And 2, 3, 42. Alright, let's subtract or move the x and the constant to the other side of the equal sign. And I have negative 9y equals 3x minus 42. Divide everything by negative 9. And I have y equals, this would be negative 1/3 x plus 42 divided by 9. Let's divide 42 by 3. I get 14. 9 divided by 3 is 3. And because those are both negative, that's going to be a positive. Awesomely, I have the same slope for each line, which is good because both of these lines that we came up with the equation for, both of these lines are perpendicular to AB. So they should both be the same slope. Okay, I found an equation for this line, which is right here, and I found an equation for this line. So through A and through B. Cool, let's try another one. So same type of problem, exact same type of problem. So I'm actually going to push pause and try to work through this and see if you can mirror what we did in the last slide and do it again on your own. Alright, there we go. We have 2 answers. Go ahead and push pause, and if you didn't get the same answer that I did, maybe one of us made a mistake, or maybe you made a mistake, or maybe I made a mistake, or maybe we both did. But go ahead and look through them. It should make sense. It's the exact same type of problem as the last one. Cool? Alright, same type of problem again, given 2 points. Write an equation for the line through S and perpendicular to ST, and then through T and perpendicular to ST. So I'm going to push pause again and work, and I'd like you to try this one on your own and see if you get the same answer. Awesome. Alright, there you go. I was able to simplify that y-intercept a little bit further, so I went ahead and did it for the second problem, not for the first one. The first one, I couldn't simplify anything, so please push pause and see if you got the same answer that I did. And please ask tomorrow if you didn't, okay? And actually, that's all we have for today. It was a pretty quick lesson. It's really using a lot of the stuff that we've learned already. So there's a few problems that I'm sure you're going to do awesome with. Cool? Alrighty. We'll see you tomorrow.